So let's work an example of converting complex numbers between the different forms. So we want to convert the following complex numbers from the form given here into the remaining two forms and then plot them on the complex plane. The two numbers being c is equal to 6 at angle 30 degrees and c equals 5.2 plus j.3. So let's start here. We have 6 at angle 30 degrees. That one's relatively straightforward to convert into exponential form. It is just 6e to the j 30. That's the direct conversion, so not much needs to be done there. If we want to convert that over to rectangular form, a is going to be equal to 6 times the cosine of 30. If you're using a calculator, make sure it's in degree mode. And b is going to be 6 sine 30. And then we end up getting 5.2 plus j3. So if we were to find this, we would go 1, 2, 3, 4, 5.2. It's a plus j, so it's 1, 2, 3. Roughly right there is the point. So that is c equals 5.2 plus j3. Alternatively, we could say it is c is equal to 6 angle 30 degrees, right? That's a 30-degree angle right there. So that's A. And B, if we start with, I think the answer is kind of obvious, right? But let's just go through it for the practice. 5.2 plus j3. The magnitude of C is going to be equal to the square root of 5.2 squared plus 3 squared. And you already know the answer, but indulge me and do it in your calculator anyway. We end up getting the magnitude of C equals 6, and then theta is equal to the arctan of B over A, right? So in this case, it's going to be the arctan of 3 divided by 5.2. And not too surprisingly, we get 30 degrees. So 5.2, doing that conversion, we get 6 at an angle 30 degrees. If we were going to write that as an exponential, it would be 6e to the j 30 degrees. I'm not going to graph it because it's the same point. So now let's do an example of the need to consider the appropriate quadrant of the complex plane when performing an inverse tangent operation. So we want to convert the following complex numbers from rectangular to polar form. We've got c equals 8.66 plus j 1/2, and we've got c equals minus 8.66 minus j.5. You should be able to visualize in your head what quadrants these are in. This is first. 2 positive numbers puts you in the first quadrant. 1, 2, 3, 4. 2 negative numbers puts you in the third quadrant. So we will run into a problem using our calculators to do this. Why? Well, the inverse tangent of B over A is going to be a positive number here, and it's going to be a positive number here, so we're going to get the same result, right? So we would find out that C in both cases is equal to the square root of a squared plus b squared. The squaring operation gets rid of the negative signs in part B here, and so it just ends up being 0.866 squared plus 0.5 squared. Take that quantity to the 1/2. And what does that result in? 1. We get a magnitude of 1. If we take the arctan of 0.5 over 0.8 0.866, you will find that that is equivalent to the arctan of minus 0.5 over minus 0.866, right? The negatives are going to cancel there. What this turns out as 30 degrees, right? So in both A and B, when you do that arctan function, you're going to get 30 degrees. Well, this has to be in the third quadrant. So how do we do that? Well, we just add 180 degrees. If the point's here and it needs to be in the third quadrant, we just are rotating 180. So the answer to A is going to be 1 at angle 30 degrees. The answer to B is going to be 1 at an angle of 30 plus 180 equals, that's not plus 18, plus 180, 80, 90, 100, 110, or 210. 1 angle 210 degrees. So, some calculators may be smart enough to catch that. Most TI series calculators aren't. So you got to outwit your calculator in this case and realize that you need to be in the third quadrant.